Before, would you like to buy our new siren synthesizer?
That's so cool! 8 different sounds. Oh, only 6. 6 different sounds. Oh, but lots in between. What is that, Wade? 6 factorial?
Yeah.
Yeah.
And lots of fun. Check this out. Is it Pac-Man? Is it,
Galaga?
Is it Galaga? Is it, that other crazy game? I can't remember what it was called. Galaga 2? Oh, the possibilities. Here, you could do Morse code. Wait.
Why does it look so terrible?
You look terrible. Gosh. Hey, I made it.
Hey, why don't you tell her about the beautiful breadboarding?
Oh, here, please. Observe our beautiful breadboarding technique.
What is that?
Beautiful breadboarding technique involves up and down. Wait. Up and down wires with sideways wires also. Very few wires are allowed to travel in a diagonal direction.
In fact, no wires.
Yes, assuming we ignore all of these wires here. or these ones, these two. These wires, well, those ones are freebies.
Those are to output and input,
Yeah.
Mr. Wade.
They're freebies. So anyway, we've got our red here, and that's our hot wire. And it's our 9-volt bar. It goes all the way across. All of these little holes on our breadboard are 9 volts. And then our black wire goes down here, which is our 0 volt, or our ground. Some of you might be familiar with this term, having taken a physics course or electrical engineering course before. Now, our 555 is a very sensitive chip.
How many did we blow out?
I believe that this thing will break at the slightest swing from a hammer.
Wow.
Anyway, so we've made some
So
additions to our circuit. We have made our circuit mobile with
Look
a
at that
9-volt
shit.
battery. Ooh, yeah. Yeah, now you could just pick this up, put it in your pocket, maybe strap it around your waist with a handy utility belt, and you could play a love song for your favorite, dearest gal.
Or guys.
Sounds a lot like an organ. Or a fart.
We're getting some good stuff.
All right, now some of you might be wondering, well, that's pretty interesting. How would I make one? Well, right here we have a poorly drawn circuit.
Hey, those lines are straight.
Oh, yes. That's, oh, never mind. Anyway. I'll leave your mother jokes for later.
Oh my god, to know how to make the noise.
So anyway, we've got our 555. Down here we've got our switch relay. We've only drawn 2 here, but you can see that we've got a good 6 of them.
And you can extend them,
Yeah, we could extend this if we had more boards and more, I don't know, if we cared to make more switches.
Yeah.
Like we could have
We
tons
could have
of
a
these.
full 86 key keyboard.
Yeah.
Is that how many keys are on a keyboard?
There's 88 actually.
88. Dang
Yeah.
it.
Yeah, so you and 8 of your friends could play on the keyboard, and you'd have 2 pinkies left over. Anyway, so some finer details about this circuit.
That doesn't make sense.
You don't make sense. Look, you invite 8 of your friends over to play on an 88 keyboard.
That's 90 fingers.
Yeah, that's why you have 2 pinkies left over. 90 minus 88 equals 2 pinkies. This is an important lesson that we have learned on this project.
Oh, speaking of lessons that we learned, what else did we learn on this project, Wade?
Oh,
Not
yes.
how to make the noise.
Well, we learned that the pitch or the frequency of the 555 is dependent on the capacitance and the resistance ratios going into, oh, let's see, it's going between the what is that, the 1 pin and the 2, 6, and 7 pin. Okay, so this here was the original potentiometer. We added these ones here. Those also control pitch. This one is the main pitch board though. If you change this resistance, you'll change the pitch of every single one of the keys that we have on our organ. And that's this 100K resistance potentiometer here. So you can hear it go up in pitch and go down in pitch as I move it left and right. Now, we added these potentiometers here, which you can see as these gray potentiometers. And what's great about these is they change the resistance value found at each connection. And doing so allows us to individually tune each of these keys. So if I'm playing this key and I move this potentiometer, you can hear a difference in pitch. But while I'm doing so, you won't hear a difference in pitch in any of our other keys. This allows us to make a fine-tuned instrument. Now, what good is this, you might ask? I might ask the same thing of you. Yeah, you could send in your answer to Dwight's email. Just look him up on Portal. You know, I think there's some pretty good pictures of him on his Facebook too. You should try friending him on Facebook and telling him what you think about this wonderful video. Thank you, and good day.